Hello, this is Mr. Civil once again. Please welcome to my YouTube channel. If you have not yet subscribed, please subscribe and press the bell notification button to get all my latest videos. In the previous example, that was example 4, I taught how to calculate the maximum and minimum intensity at the base when you are given a superimposed load. So in today's example, we shall look on the wind pressure and the liquid pressure. So let's get started. First of all, we shall look at the wind pressure. So the question says that a vertical wall of height 3 meters is subjected to a uniform horizontal wind pressure of intensity 1.2 kilonewtons per meter squared. You have to determine the magnitude and the resultant thrust per meter length of the wall. So here is the solution. This is the formula that we shall use. So this is capital P is equals to small p multiplied by capital H. So our capital P is the resultant thrust per unit length, and then P is the intensity of wind, H is the height of the wall. So you can see that we have to calculate the resultant thrust P, which is equals to 1.2. This is the intensity of the wind pressure multiplied by the height of the wall, which is 3 meters. So when you will calculate this, you'll get your answer as 3.6 kilonewtons per meter. And then now we shall calculate the magnitude. So the resultant strikes the wall at a height of h all over 2. So this is the center point of the retaining wall. This is where the resultant thrust will act. So that is 3 all over 2, which is 1.5 meters. So the thrust of 3.6 kilonewtons per meter will act at 1.5 meters above the base. So that was all about the wind pressure. Now we shall look to the liquid pressure. So also we are given a question. A masonry dam of height 6 meters retains water on its vertical face. Calculate the resultant hydrostatic thrust acting on a meter length of wall when question A says that the water reaches the top of dam, and then B when the level of water is 1.8 meters below the top of dam. Then we are given the density of water as 1000 kilograms per meter cubed. So this is the density of water. First of all, we shall calculate question A. So we shall calculate the hydrostatic pressure, that is PW at 6 meters. So 6 meters is when the water reaches the top of the dam. So this is the formula that we shall use. P is equals to rho W, this is the density of water, multiplied by G, this is the gravitational acceleration, and H is the height. So this one can also be equal to gamma W, which is the unit weight of water multiplied by the height. In our case, we are not given this, so we shall use this formula. P is equals to rho W G multiplied by the height. So the hydrostatic pressure W will be equal to the density, which is 1000 multiplied by 9.81. This is the gravitational acceleration multiplied by 6. So you'll get your answer as 58,860 newtons per meter squared. So this is the hydrostatic pressure that is acting at 6 meter depth. Now we shall calculate the hydrostatic thrust. So we have our formula P is equals to PW multiplied by the height all over the density of water multiplied by 2. So this is the formula that we shall use to calculate our hydrostatic thrust. This one PW, we got it as 58,860 multiplied by 6, which is our height, and then divided by the density of water, which is 1000 multiplied by 2. So when you calculate this, you'll get your answers 176.6 kilonewtons per meter, acting 2 meters above the base. So when you want to calculate how it is acting, our P will be equal to H all over 3. So for our case, our H is 6 meters all over 3. So our P will be 2 meters. So this means that this pressure, hydrostatic thrust 17.6 kilonewtons per meter, will act at 2 meters above the base. And then the second question, you are to calculate the hydrostatic pressure and hydrostatic thrust, but this time our level of water is at 1.8 meter from the height of the retaining wall. So we have to note that the depth is always measured from the surface of the liquid. So I'll take 6 minus 1.8. So I'll get the length from the base to where the surface of the liquid reaches. So I've calculated and got as 4.2 meters. So this means that the water surface is 1.2 meters above the base. Then we shall calculate the hydrostatic pressure. So we shall use the same formula. PW is equals to rho W multiplied by the gravitational multiplied by the height. So in this case, 1000 is our density multiplied by 9.81. This is a gravitational acceleration multiplied by 4.2. This is our height. When you calculate that, you'll get your answers 41,200 newtons per meter squared. And then we shall calculate the hydrostatic thrust P, which will be equal to 14,200 multiplied by 4.2 all over 1000 times 2. So the formula I've given it previously, so you can have a look on the formula. When you calculate this, you'll get it as 86.5 kilonewtons per meter, and then this will act as at 1.4. I also taught you how to calculate at the point where it acts. So our P is equals to the height all over 3. So our height was 4.2 divided by 3. So when you divide this, you'll get your answer as 1.4 meters. So this means that this 86.5, the hydrostatic thrust, will act at 1.4 meters above the base. Thank you very much for watching my video, and have a good day.